Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam Harris.
And I'm Kim Montague.
And we're here to suggest that real mathematics is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental relationships. We answer the question, if we're not using algorithms, then what are we doing in mathematics? All right, I really like the title of today's episode. This, not that.
Yeah, we're going to share some of the things that we hear our fellow educators or parents say that make us cringe just a little bit and offer some alternatives that are much more mathematical. So, Pam, we're going to start right off. And I know that one of your personal favorites is add a zero.
Oh, we have to start with that one. Okay, yeah. So when we multiply by 10 in our really cool base 10 system, you know that there's this zero thing that happens, right? That when we multiply by 10, it's sort of that many tens. And so we have 0 ones. And so there's this zero that shows up. But it makes me slightly crazy when people say, oh yeah, just add a zero. Because when I was in kindergarten, if I had 5 puppies and 0 puppies crawled in the room, then I didn't have 50 puppies, right? You're not like adding a zero. It's really more about multiplying by 10 and what happens in our base 10 system when you do that. So when we multiply by 10 or divide by 10, it's not about adding a zero. In fact, really quickly, if we're multiplying decimals by 10, you can't add a zero. 3.2 times 10 isn't 3.20. It just doesn't. So we don't want rules that expire.
Right.
So yeah, we don't want to talk about adding a zero.
So also, I think that what I should have mentioned earlier is that sometimes it's less that people don't know the right thing to say. I think sometimes we get a little bit sloppy in our language. So I think
a little bit lazy.
Maybe this is a sloppy one. But when we want kids to be thinking about multiplying 10 times greater or 10 times a number, sometimes we say 10 times more than a number. But when we divide by 10, we don't want to say 10 times less. We want to say 1/10 of.
Yeah, so 10 times more could be like adding 10. 10 more would be like adding 10. 10 times a number is a great way to say it. A tenth of a number is a great way to say it. Here's another not a great way to say it. Don't butt cheek. When I mentioned the other day, when I mentioned that we're multiplying by decimals, some teachers will say, "Oh, now you don't add a zero. Now you just butt cheek." The first time that came up, Kim was actually working with a 7th grade kid, and she called me and she's like, "Hey, this kid just is talking about butt cheeking." And I was like,
that?
"Oh, yeah." I'm like, "Oh, that's an unfortunate thing that sometimes, again, in our sort of sloppy language, we kind of treat this idea of multiplying by 10 as just like moving the decimal, and our attempt to kind of make math cute or help kids remember, like if you move the decimal, you sort of draw these butt cheeks on that. I mean, Kim, I'm from a good little Mormon family. We don't even say the word butt. Since you brought that recording to me, yeah, now I'm just all over the place. We're talking about butt cheeks.
Sorry about that.
Unfortunate. Butt cheeks do not belong in mathematics. Let's be clear.
Right. And so actually that's part of a whole place value conversation, right? And so we're going to have a whole podcast series about place value because it's definitely a big topic.
Yeah. So just briefly, when you're talking about times 10, talk about the pattern in our number system where you have that many tens, and so there's the zero that shows up because it's sort of telling us how many of the ones are in that one. It's not about butt cheeks or adding a zero. Okay, cool. So here's another fave. I'll shoot back at you, Kim. How about the word cancel? Woo! We like that one, right?
Yeah, that's important.
Okay, so what's wrong with the word cancel? Cancel's so helpful because it comes up so many places. But y'all, that's part of what's bad about using the word cancel or difficult about using it, because it shows up in so many different places to actually mean different things. And if we're not really explicit about what's happening, kids just start to cancel everywhere. So you can appreciate sometimes we might have something like negative 2x plus 2x. And sometimes teachers will say, they just canceled out. Well, could we talk about that negative 2x plus 2x as adding to 0? Or we might have just negative 2 plus 2, and those add to 0. And if we have 0 in this equation, then we can sort of deal with the fact that we have now 0 there. Because if it just sort of cancels, then what's left there? Well, it's kind of important that they sort of added to zero. And so now we know we have a zero left that we still have to deal with. Why is that important? Well, because another place we often use the word cancel is when things are a thing is divided by itself. So we might have 5 divided by 5, and especially if it's in kind of like a rational thing where we have 5a squared divided by 5b squared, then people might say, oh, the fives cancel. Or if we're simplifying fractions, we might those factors cancel. But do those cancel to zero? No, they cancel to 1, right? See, I just use the word cancel. They divide out to 1. A thing divided by itself is 1. Now in that multiplicative relationship, I have a 1 hanging around. Oh, well, that's hugely different than having a 0 hanging around in a multiplicative situation. So it's important that kids actually talk about what's happening and not use this word cancel that can get used to mean way too many things. Let me tell you, as a high school teacher, I start to get them that if it looks like a fraction, like a rational things, things divided by things, they just start to cancel everywhere. And all of a sudden, they look at a say fraction addition question, and they say, let's see, this is where I find a common denominator. No, this is where I invert and multiply. No, this is where I multiply straight across. Or my favorite, this is where I cross cancel, which isn't even a thing. So we want to be careful about how we use this word cancel. I would prefer that we actually talk about what's happening in that situation so kids are mathematically aware of what's going on and it doesn't become this crazy cancel everywhere.
Yes. And so speaking of canceling and fractions, sometimes we ask kids to do my favorite thing, which is called reducing. And it gets me every time because the number doesn't get smaller, right? We're not reducing the number. If I move from 6/8 to 3/4, the number's not getting smaller. In fact,
hey, Kim, you can have 6/8 of the pie, but I'm gonna have 3/4 of it. That would be smaller. If we reduced it, I want the 6/8. If 3/4 is reduced, if it's smaller, I want the bigger piece.
Right. It's just silly. And actually what I was thinking about the other day was that in fact, the size of the pieces in a part whole scenario are actually getting bigger. So when we say reduce, the size of the pieces are getting bigger. We just get less of them, right? So we're going to all agree from this
Wait. Get specific. Not everybody can picture that. So you're saying if I go from 6/8
yes
to 3/4
yes
in some textbooks and it's horrible that even textbooks will say reduce. But if I go from 6/8 and I quote unquote reduce it to 3/4, you're saying that the size of the pieces were eighths. But now they're bigger. They're actually fourths. So we're reducing the fraction, but the pieces are getting bigger. So how about if we just decide not to use the word reduce when we're talking about fractions at all?
Yes. So let's use simplify.
Yeah, which I actually don't love, but at least it's a little bit better. It's funny, staying on reduce for just a second. I actually have some colleagues who I respect. They've got great work, who said to me one day, no, we could use reduce because it's reducing the number of factors in the numerator and the denominator. So, okay, that was a great attempt to make sense out of a really bad name, like a really bad term that we use. So good job trying to make sense of it. How about if we just don't use it? Like, neither you or I really like simplify a ton. It's not like our favorite, but it's so much better than reduce that if you have to use one of the two, let's use simplify. Okay, cool. Let's do another example. So Kim, I'll shoot another one back at you. Often when I work with middle school teachers will get on me a little bit when I will say something like 3.2. So earlier I talked about 3.2 multiplying by 10. You don't want to add the 0. You also don't want a butt cheek. But I said 3.2. What I didn't say was 3 2/10. Right. Now I could have, right? The name for 3.2 is 3 2/10, but it's also $3.20. Yep. And I think we need all 3 of those. So I know middle school teachers get kind of excited. Hey, if we were to use correct language, kids would understand better. So I have a case in point. I can give you a specific instance where it didn't help to use the language. Are you ready? Yep. I had a personal teacher who forced me to, whenever I talked about a fraction, I had to give it its fractional name. Didn't help me one whit. Like I memorized what the fraction names were. It didn't ever occur to me how they influenced what those 3.2, 3 2/10. I could say 3 2/10 till the cows came home. It didn't help me think about that number any differently. So just using the vocabulary doesn't necessarily mean that we're also helping to have the kids think differently. However, I do think we should use all three. So if I'm talking about 3.2, I think sometimes I say 3.2, sometimes I say $3.20, and sometimes I say 3 2/10. And I think we need all three of those, but not just using the names. We also need to help kids understand why we're using the names, what the names actually mean. So I think we need all three of those descriptions.
Right. And I feel like that's part of the place value conversation that we're going to have a little bit more in our multi-part series. But I've also heard you mention that we want to have language that is part of the masses, right? So we talk about our national debt.
Oh, yeah. Yeah. How often have you heard a politician say, oh, let's see, right now our national debt is 4.2 trillion or 4 2/10 trillion or
Yeah.
what? I don't even know what we're at right now. I'm
We say
throwing out some
4.2
random number.
trillion. Yeah.
No one ever says 4 2/10 trillion dollars. It's not a thing. So yes, thanks for bringing that up. We do need to have the popular sort of nomenclature also happening. So kids are sort of clear that all of that's legal to use to name those numbers.
I've got an admission. The thing that I continue to need to work on is I say over a lot. I say over a lot, and I'm working on it.
Well, so let's be picky. Over when do we not want you to use over?
So if I'm writing a fraction and I'm describing it to somebody else, I will say 2/3
for 2/3
or 2/3.
Yeah. So that's tricky, right? Because if you're trying to like help a young learner like figure out how to write 2/3, like you might say, the 2 goes on the top, we call that the numerator, and then the 3 goes on the bottom. I mean, you might use positional words to sort of help that youngest learner kind of figure out how to represent that's social knowledge. So we have another podcast on social knowledge if you want to go listen to that one, but it's social knowledge about how we're going to write that fraction. And you might use positional words, but over is a positional word. It's not a mathematical word. It doesn't describe a mathematical relationship. So when you are talking about 2/3 and you say 2/3, then you're describing a position, not a mathematical relationship. So Kim, as long as we're admitting, that is probably the hardest one for me as well. Not honestly so much with fractions, but with rational expressions. So if I'm talking about x, the parent function for rational functions is 1/x. Oh, or I mean 1 divided by x. That is so difficult when we have because of tradition. Like I've just heard it that way so often that that one has been a difficult one for me to switch. So what can we say? So instead of saying 2/3. What else how can we name that fraction?
Yeah, so I definitely like 2 divided by 3 better because it's mathematical.
2 1/3.
2 1/3.
A way of talking about it. When I'm talking about 1/x, I can talk about 1 divided by x. I can talk about the ratio of 1 to x. I can talk about the rational function of 1 divided by x. So those are going to be better ways that then accurately reflect the mathematical relationships that are happening. But again, we recognize, you hear Kim and me talking about how over is hard for us. Reduce might be the one that's hard for you. There might be some of these sort of non-mathy terms that kind of get in the way that we're used to. They've been tradition. We've sort of heard them a lot. That it might take you a hot minute to sort of take them out of your practice. But we would just encourage you to work on that. We would encourage you to work on making your mathematical vocabulary as precise as possible. That will help your students understand. It will help them not. I'm about to do lots of negatives. It will help them not misunderstand as much. Hey, and I've got one for you, Kim. So here's one that I didn't really understand when I first sort of ran into it in the state of Texas. I would hear teachers get really picky about the word "and" when they were talking about numbers. And I was like, why are you guys being so picky? Can you help me out with that? Like, where does "and" belong and not belong? And what are they getting picky about?
Okay. So I feel like this is a conversation from testing situations that happened years and years and years ago. But a lot of teachers will say that you cannot say the word "and" in a written form or when you're saying a larger number. Like, for instance, you cannot say 107. It would be 107. That it's mathematically incorrect to say 107.
So mathematically incorrect. I mean, maybe, but the reason I think I agree with you. The reason teachers are making this big deal out of what is not a mathematically important thing, this word "and," is because like you said, it was on a high stakes test. So in the state of Texas, when TOS came out, kids had to write out numbers in words, and if they put the word "and" in 107 or 356, if they said 356, then they were marked wrong. And so it became kind of this hyper vigilance of teachers to know, oh, don't put "and" in the wrong place. That was a stupid test question. Like, we shouldn't have asked that. That's not important mathematically, and to make a big deal out of it is sort of nonsensical. Where should we say "and"? I think it's what, 3 and 2/10. So 3.2 is 3 and 2/10. That's where we can say "and," like, technically. And so teachers won't mark it off if I say 3 and 2/10, but they'll mark it off if I say 302. It's like, that's not important. So let's not make a big deal about using the word "and" within numbers, especially big numbers. Not a big deal. Let's focus on the mathematical relationships and not on picky things that were once tested long time ago. All right, you guys, today we've tried to map out just a few of our favorites, this, not that, kind of things in mathematical vocabulary and terminology. We'd like to share some more in the future, and we've got more to share, but we're also interested in some of yours. So if you guys want to send us your faves, this, not that, then that'd be great. We'd love to hear from you, and we'll add them to the list.
Awesome. Don't forget to join us on Math Strat Chat on your favorite social media on Wednesday evenings. And if you haven't yet, go watch the problem strings on the website, where you'll see us work with students to pull out their thinking and reasoning.
Yeah, so mathisfigureoutable.com/PS for problem strings, and you can watch us work with real kids, pull out their thinking and reasoning. Lots of fun. So if you are interested to learn more math and you want to help students develop as mathematicians, then the Math is Figureoutable podcast is for you, because math is figureoutable. Hey, fellow mathematicians. You know what, Kim? Hang on a second.
I want to keep that sometime.
I want to stand up. I'm making my desk go up.
Okay.